Okay guys, so we're going to have a look at the reaction of alkenes with hydrogen halides, so hydrogen chloride, hydrogen bromide, etc. I'm going to look at how we work out what the product is in these firstly, and then we're going to look at how we work out if there are two possible products, which one is the major product and which one is the minor product. Now this is all based on the, as you can see here, which carbocation happens to be made during the mechanism, during the reaction. So you might want to refresh yourself, if you're not already, the mechanism for the reaction of alkenes with halogens or hydrogen halides, and see how you work out where that carbocation actually comes from. So we'll look at some very simple ones, and we'll then make it a little bit more challenging, sort of more exam style problems, and hopefully that will clear up any issues that you have here. So we'll look at, first of all, we're just looking at plain old ethene here, reacting with hydrogen bromide via this is in case you didn't know it already, this is an electrophilic addition reaction where the hydrogen bromide acts as an electrophile, accepts a pair of electrons from the pi bond, specifically within the double bond, and then adds on across the carbons in the double bond. So it's always the carbons in the double bond which are the center of everything that's going on. Obviously that's the functional group here, and that's probably as you would expect. But if you know the mechanism, you know that anyway. So let's look. So the hydrogen bromide, this is, as I said, an addition reaction. So the hydrogen and the bromine will add, and it will add to the carbons in the double bond. Now, the hydrogen could attach to this carbon and the bromine to this one, giving us this product. Alternatively, the hydrogen could attach to this carbon and the bromine to this one, giving us this product. Now, most of you probably already realize that those two products are exactly the same. So in this particular instance, when we have a symmetrical alkene, we only get one product. Okay? So if we look at the carbocation that would be produced in each case, so the hydrogen attaches to this carbon and leaving the other carbon in the double bond as a positive carbocation, and alternatively the hydrogen attaches to the carbon in the left of the double bond, leaving this carbon as a carbocation. So therefore the bromine will attach to this carbon in this instance, and the bromine would attach to this carbon in that instance, giving you your two products. But if you look at it, the carbocation is absolutely identical in both instances. It's just swapped, okay, 180 degrees they are turned around. So you get two products which are exactly the same. Okay, let's look at one that's a little bit more complicated. So in that one, sorry, we have no major or minor product. The two carbocations are identical. They come in a 50-50 ratio, so you'll get a 50-50 mix, and you only have one product therefore. Okay. If we have a look at this one here, you'll find now if I drew a line of symmetry down this one, it is an asymmetrical alkene. So that's when we immediately know that we will get two different products. Okay, so that's the quick way. Now we've got to work out what are the two products and why do we get them. Well, if you remember, this goes by a carbocation mechanism. So the carbocation could be there, or it could be there in the mechanism. So if we look at the hydrogen attaching to the carbon in the double bond, the left-hand carbon in the double bond first, okay, we get this, and our carbocation therefore is in the right-hand carbon from the double bond, whereas down below the hydrogen attaches to this carbon in the double bond, leaving us with the carbocation on this carbon. Now what's the difference between these two? Well, we have different types of carbocation this time. Unlike here where the two carbocations were identical, this time we have what's called a tertiary carbocation. So my carbocation, my positive carbon, is attached to 1, 2, 3 other carbons. That's tertiary. And down here my primary carbocation is attached to only one other carbon. So this is a primary carbocation. Now, the basic rule is that tertiary carbocations are the most stable of the lot. Secondaries are second most stable. So tertiary is most stable. Secondaries Next, and primaries are the least stable of that. And really all we're saying there is that it takes less energy to make a tertiary carbocation than to make a primary. And if it takes less energy to make a tertiary carbocation, we're going to have more of it. Then, if we have more of this, there is more opportunity for the bromine to attach to that carbon. So this, therefore, is our major product. We're going to get more of this because as the intermediate in the mechanism, we get more of the tertiary carbocation, and therefore the product which comes via our primary carbocation here, okay, is our minor product. We've got less of it. Okay, so let's have a look at another one. So that was tertiary versus primary, and tertiary is more stable than primary, so we get more of that. Let's have a look at this one again. We can draw a line of symmetry through the double bond and see that it's an asymmetric carbon. So if we have a look, again we have two potential places for our carbocation to form, either here or here. So I've drawn them both out over here. So if we look at this one at the top, first of all, we can see the positive carbocation has got 1, 2, 3 other carbons attached to it, so it's tertiary. Whereas if we look at the alternative possibility, we have this carbon becoming the carbocation, and that is to attach 1, 2 other carbons, so that is a secondary. So this one is our tertiary. It takes less energy to make them, so therefore they will be made in a greater abundance than the secondaries, and therefore our bromine is more likely to attach there than it is to attach there, or bromide ion I should say. And we get our major product as this one, and our minor product as the resulting haloalkane from the secondary carbocation. Okay, so that's how we work out what our major and minor product is, and we will always be explaining that in an exam through the presence of primary, secondary or tertiary carbocation. There's also a quick way to predict what product you might have, okay, and that's called using Markovnikov's rule. Now Markovnikov's rule is only to be used when you are just working out what the major and minor product are. You are not allowed to use it to explain why that is the major minor product. When you're explaining to an examiner why something is made in a greater proportion than the other, then you've got to explain it via the presence of these carbocations, primary, secondary or tertiary. So Markovnikov's rule simply states that the hydrogen atom will attach to the carbon, in the carbon-carbon double bond of course, which has most hydrogen atoms already attached. So if we look at this example here, we're adding HCl to it. So very quickly, how do we indicate the major product? Well, there's my 2 carbons in the double bond. The one in the red square has got the more hydrogens attached to it, 2 hydrogens versus 1. So therefore the hydrogen from the HCl would attach to that one, giving us this product here as our major product. Okay, and that comes via a secondary carbocation. Okay, the alternate carbocation on this would be where this carbon becomes positive, and that would be a primary carbocation. If we look at the next one down and use Markovnikov's rule again, we look at the 2 possible carbons in the double bond. They are those ones. Applying Markovnikov's rule, this is the one with most hydrogens attached to it already. It's got 1 here, okay, as opposed to 0 here. So the hydrogen from the hydrogen bromide would attach to this one, giving us the hydrogen here, and this would of course be our major product. Okay, and again, this time the carbocation could be here, which would be tertiary, and the bromine attaches there, of course it does, as opposed to here, this could be our positive carbocation, which could be 2 carbons attached to it, would be secondary. Okay, so the tertiary carbocation, which I've drawn out for you there, gives us our major product over the secondary carbocation. So remember guys, Markovnikov's rule can only be used for you very quickly in an exam to work out what the major and the minor product would be. Okay, of course the minor product, just before I leave, would just simply be those 2 swapped, and likewise down here the minor product would of course be those two swapped, and that would have come from when they're swapped from the secondary carbocation, whereas here those two swapped would have come from the primary carbocation, giving you your minor product. Okay, hope that allows you to first of all work out what your major and minor products are, and secondly, and probably worth more marks, to actually explain why one is major and why one is minor. Okay, thank you.